My name is Russ. I'm the head engineer at Diesel Emission Service, or DES, and we make the filter therm line. And I want to talk to you guys about repeatable DPF cleaning and how to create good quality service. I want to thank, as we get started off, I want to thank NARSA and IDEA for letting us do this and just being able to interact with you guys and all this stuff that we've learned over the years and be able to give you some great info. So where do I start? We have started in the industry, DPFs and then cleaning. And so now we've done thousands of cleanings and we build cleaning equipment for DPFs. And as we've gone through, we have found that there are some key steps, key things you need to hit when you're cleaning so that you get good, repeatable, and reliable DPF cleanings. So just a quick overview of the whole DPF cleaning cycle. DPFs collect a combination of soot and ash inside them while they're on the vehicle. The vehicle then does an onboard regen, which allows it to pack in more soot and ash. But remember, it's still a filter, so it's still collecting everything. That increases the back pressure in the exhaust system, at which point you get your warning lights. So we remove the DPF, we essentially back flush it to get all the soot and ash out of it. And then we give it back to the customer who gets it dirty all over again. Imagine that. So how do we know that it's clean, what it's done? And when we're cleaning it and the cleaning schedule, what does that tell us about the health of an engine? So we're going to inspect the filter when it comes into our cleaning shop. And when I say cleaning, and I'm going to refer to a separate cleaning department or company or division, but it may be that you are you are your own shop's cleaning facility. And this will apply for everybody. So the first thing is when we get them, we're gonna inspect it. We're gonna get good before cleaning info on the DPF when it comes into our shop. Then we're gonna take some steps to clean out the captured soot and ash. And then we're gonna inspect it again after it's clean to get that same info and see how it compares and how well it's been cleaned. So I'm gonna go through all these steps, and it doesn't matter what machines you're using to do the cleaning. We'll touch on different styles and types. As long as you're using something, you're getting this good data about the health of the DPF and you're recording it. So documentation, getting your recorded data is really that jump that takes you into really reliable cleanings. Documentation is a value added for your customer. The cleaning you give repeatable info that you can then go over with the customer. We as the cleaners, we see the health of the engine in what's in the DPF and how the DPF is, or the health of the DPF. What used to be is that the mechanics would see what's coming out the tailpipe and they could tell problems, issues with the engine. They could tell if the engine was running rich or lean, or if it was just, spot on. But now all that is being captured in the DPF, so we see all that. So based on the info that we get and pass on to our customers, the customer can now see those trends of how long they're cleaning, or if there's issues. They can be proactive with the data that we're collecting and giving to them. So documentation also covers you. It covers you as the cleaner. You make sure your process is working correctly. A lot of times, if one of your machines isn't working right, you'll see it in the data that comes out at the end of the cleaning. We can also catch, so we can catch if something is going wrong with one of our machines. And heaven forbid, if there's ever a legal issue, it's no longer your word against their word. If a bad DPF goes back on a vehicle, or if you get bad filters from the start, you've documented that and you were able to know that you told them was a bad DPF. So here on this slide, I'm showing an example of the software that we use. We developed tracking software, and we use this on all of our cleaning facilities. Basically what it does is it captures customer info, DPF info, and the data from each of the steps that we're going to talk about. So hopefully you can see this, but in the bottom left, first we collect the customer's info, and then we collect the filter serial numbers and info on the truck. The software allows us to see the previous services that happened, so we know when it was cleaned last or over and over. Then we have a section that collects this data that we're going to get in these next steps I'll talk about. And this is an example. We took pictures of the DPF beforehand, so the customer knows what it looks like. So we knew what it looked like. And we took pictures afterward. And again, so we know what it looks like afterward. And then finally, in the upper right, we have a printout that we give or email to the customer, so they have that for their records. So now we move into these steps that we're going to gather data and document so that we have something to give the customer and that we learn about this DPF as we're going through. So I'm going to talk about what we're doing and what we're looking for. And at this point, we're going to get our hands dirty. We're going to get on the DPF. So please use the correct PPE. The soot gets everywhere. You don't want to be breathing it. You really don't want it all over you. So please be careful with it. And we're going to do these steps before, and then we're going to do these same steps after cleaning, and we're going to see what the difference is. So first, we're going to inspect visually. We're going to look at this. We're going to look at this DPF, and on the previous slide, that's what those pictures were for, is the technician looked at the DPF, took pictures to be able to record what it looked like. We're going to look on externally. We're going to look on the housing. We're going to look for dents, cracked inlet flanges, damaged sensors, bungs. I've even seen heat shields that are come unwelded and are rattling around. And any of these could also be an indicator of internal damage. If you get a huge dent on a filter, they're pretty robust, but it could damage the internals. So then we're going to look at the filter ceramic. And we're going to look for things like, is it shifted in the housing? Is it nicely centered, or is it off center and pushed to one end? We're going to look for foreign objects. I've seen chunks of turbo vane stuck in a DPF, parts of the DOC that was before it stuck in it. So, and then we're going to also look and see, hey, is it melted? I've run into DPFs where as soon as they come off the truck, you can tell immediately that there's a internal melted issue. And if we find something that makes this a no-go for our cleaning, we don't want to go any further, we're going to tell the customer. And at any point, this kind of applies to any one of the tests that we're going to look at, that we're going to get data on. If we find something that says this DPF is bad, this DPF should not go on a vehicle, I'm going to communicate to the customer. So then the last, so we've looked at the externals, we've looked at the ceramic filter itself, and then we're going to look at the soot. Is that soot dry and oily? Dry or oily? And is the filter still acting like a filter? Is the inlet dirty and the outlet is clean? Because there's a situation called bypassing where the soot either gets pushed through the cells because of a crack or damage, or it actually goes around through the matting and you'll see that soot on the outlet where you shouldn't see it at all. And then is the soot going into the holes? So there's a situation called face plugging where the engine doesn't provide enough pressure to push the soot down into the cells where it's supposed to be stored. And the soot just cakes up right on the surface of the filter. And it essentially plugs the face. So we're going to be looking at those different things. So now that we've looked at the exterior, now we need to get some info on the interior. We're going to do a wire test. So if you see this picture on the upper right there, we have soot comes in the inlet cells and then passes through the wall and out the outlet cells. And you can tell inlet versus outlet because every other cell is capped. So if we take a thin wire to the inlet, we can put it down into that soot and ash that's being stored in there. And we can give a really good indication of the health of the DPF. So the actual process looks like this. We start by putting a wire in the outlet cell. Now I said before that the inlet should be clean and the inlet should be dirty and the outlet should be clean. It's because there should be no soot packed up in the outlet. So the outlet is an unobstructed cell and we can measure the full length. So we take like a 30 thousandths welding wire. We use a stainless steel TIG wire. And you can get them at pretty much any welding shop. You take that 30 thousandths wire and you put it in the outlet. And that will give you the full length, close, because the caps are about a ½ inch, but it'll give you the length of what your soot, your inlet side should be. So you're going to mark that length, and then you're going to switch over and start putting that wire in the inlet side. So soot and ash should be soft and fluffy. So when you stick it in, when you stick that wire in, how does it feel? Is it soft, or is it maybe wet and sticky? In which case you might have some fuel, some oil, or some coolant, which is coming down the exhaust with the soot. And then there's a situation where you might feel kind of a crunch or maybe a dead end partway down that cell. So this can be ash, which is melted together, or sintered, and it's kind of created like a cemented plug part way down that filter. Oftentimes you can tap that you can tap that wire down on top of the sintered ash, and it'll bust right through, and that'll kind of give you a sense of how bad or how thick that plug is. So when we stick it down and we feel that crunchy or a dead end, it could also mean that this filter is already melted on the inside. And the way you can tell is if you put the wire on the inlet and it stops, and then you switch over to the outlet at the same area and you put it in and it also stops. And that will give you an idea of, do I have a melted area inside? Because my outlet should be completely unobstructed. So once we've tested interior or exterior, interior, we're going to weigh the filter. So this is going to be a before and after comparison. So now we're taking our before. We're going to look to see later, how much did we take out? And this gives us idea how much is packed inside. Now there's not much soot and ash in there. It doesn't weigh a lot. So the industry usually measures this in grams. So when you do this, when you weigh, what you're gonna want to do is make sure you've cleaned that DPF of all of the extra items, dirt, old gaskets. You want to take off any mounts, clamps, or sensors. And then once it's all clean of all that external stuff, then go ahead and weigh it. One of the things is you may find that there's a broken sensor or a bung that needs to be replaced. Just wait till after the cleaning to do that replacement. Because you've weighed it now, you don't want to change your filter while you're in the process. So we weighed it. How much is, now we're going to flow it. How well does this flow? How well does air flow through this filter? And most of the industry does this by measuring the amount of restriction to the flow. So the higher the number, the more restriction. And conversely, the lower the number, the less the restriction. So this is a bit tricky because a large filter that's dirty may actually flow better than a small filter that's clean. So for instance, a 12 liter will flow much differently than a 6.7 liter. So you want to be sure that you have equipment that can handle those large flow rates for the bigger filters, and can also handle the high restriction required by the small filters. Heavy duty trucks that we see on the market, they have really high flow rates, and test equipment that has small flow rates, they can't really handle effectively measuring the flow rate of a heavy duty large filter. So then we're gonna look for cracks. We're gonna shine a light through it. So this, in the beginning, this test works best when a truck has gone through a regen and the customer is handing you a filter that has just been regened. You qualify that. In the beginning, in this first step, when we get a clean one. Part of that is when we get a filter that's been regened, we can't necessarily see what the soot patterns look like. It's all been cleaned. It's all been cooked. All the soot on the outside has been cooked to ash. So using a crack detection at the beginning is really good on a filter that looks clean right out of the truck. As you look through it, you shouldn't be able to see any bright lights coming through. The cells are very long and straight, and you need to look right down through the cells to see all the way through it. In this picture, we actually had a pretty damaged DPF, and this is a sample of a really damaged DPF. Put it on one of our cells so you could see all of the light coming through, and especially in the center there on the overview picture, you can really see some damaged situations, damaged cells. So it really helps you see that major internal damage. So now we've done our inspection, and we are gonna move on to cleaning out that soot and ash. So if an after treatment on a vehicle is regenerating at 100%, we would only ever get ash. but nothing's ever 100%. So we get in our DPF, we get layers of ash and layers of soot all packed together. So the first thing we want to do is we want to remove as much of that easy stuff to get out as we can. So we're going to use a de-ashing. We're going to remove as much of the ash as we can. We're going to use a de-ashing system. Now, when you look for systems, make sure these all trap that removed ash in some sort of high efficiency filter system that you can easily dispose of. This will protect your users from all the crazy hazards of soot. Hopefully you're wearing your PPE, but having a machine that captures that well and lets you dispose of it really easily is really key. So on the screen, I have a couple of examples of 3 different philosophies of de-ashing. So on the left there, let's see here. Hang on. On the left here, we have a pulse machine. So the pulse philosophy is to take a blast of high volume, low pressure air and shoot it through the DPF backward in the opposite direction of flow. The pulse and the air volume push that soot out of the cells. So the second machine is using water to clean the soot out of the cells. It's basically soap and water. Now, it's a specially formulated additive that removes diesel soot and water flow, some really good water flow through the DPF to remove all the soot, which is captured in a set of filters. So far as I've been talking, I'm sure most of you have seen aftermarket or OEM filters. There is a smaller retrofit market, Texas, New York, California, where some of those retrofit manufacturers used a matting, and the matting is the material that holds the filter substrate in the housing. That matting material was not made to handle water. So if you're ever doing OEM or retrofits, all those are pretty good with water. But if you run in, aftermarket or OEM, but if you run into retrofits, just check with the manufacturer about cleaning it with water. So this third style here on the right is an air nozzle style, and this uses 2 air nozzles, one shooting in the inlet and one shooting in the outlet of the DPF. It breaks up the ash, and it blasts it out of the cells. So once we've got all of the easy to get out ash, we're going to bake the remaining soot that's left in the cells into ash. So soot is it's like the charred logs left in a fire. It's not quite all burned yet. We want to get that light, fluffy ash at the end. So we want to crank up the heat and burn it away, anything that can be burned away. What's left is quite a bit less material. It's light and fluffy ash, and it's items that don't burn. Trace minerals and metals that come from the engine, the fuel, and the oil. So you're probably familiar with onboard regens, and the temperatures in onboard regens are designed to convert that soot into a much smaller bit of ash for more storage room. But in the cleaning process, we want to bring the heat up and hold it so that we know that all of the soot is converted into ash. That ash is also easier to get out of the DPF. And you remember the previous step of de-ashing, that lowers the amount of soot that we have to convert into ash. It also removes materials that's giving off VOCs. So VOCs are volatile organic compounds. They're basically vapors that are bad for you, and most of them are flammable. So we want to remove as much as possible before adding a lot of heat. Also, if you have a mass of soot that starts to burn or smolder while it's in the oven, it can actually start to feed on itself and get to temperatures higher than the ceramics can handle. It creates a hot spot that then melts the inside of your DPF. So the de-ashing also removes a lot of that excess soot. If you have VOCs, if you have that wet soot that you saw earlier, you may want to run a dry out cycle first. And what a dry out cycle does is it brings the temperature of the DPF up just to the point that we boil off all of those vapors and oil, but it's not high enough that we're going to ignite them. So we do this a lot when you have oil or coolant in the soot. When you did that first inspection, it would tell you whether you're going to use a dry out cycle or not. Also, if you're using a water machine, those machines clean the soot out, but then they leave a lot of water left inside the DPF, and you want that to be dried out first. So you'll want to use a dry out cycle also if you're drying out a DPF from a water cycle de-ashing. Filter manufacturers have put out specs on what temperatures their filters should be baked at, how long to hold that, and what temperature to go up to, and how long to hold that. Yeah. So be sure to use an oven that matches or was within the specs that the manufacturers recommend, because this can be one of those contention points where a manufacturer, over a warranty issue, or a manufacturer asks you, how did you cook that filter? And then you'll have an answer that satisfies that. So once we've banked it, we're going to pull it out and we're going to run that de-ashing once again, because we've created light, fluffy ash. It's no longer sticky, and it goes and we here just to get the remaining ash out of the system so that we can then move on back to our tests, our after cleaning tests, so that we can compare them with our before cleaning tests. So this is where crack detection really shines. Now the DPF is clean, you can get a good look through a DPF to see if there's light leaks, which would indicate a problem. This is really good for larger internal failures. Now you have to keep in mind that DPF manufacturers can allow a few cells that have bad caps to go through the production process. This is because their filters are so efficient that even with a few caps missing, they can still meet the filtration levels that are required by law. So what you'll want to be looking for is you'll want to be looking for light coming through in a crack style or in several kind of melted together filters all at once. So we're going to do our second flow test. And we're going to see what we want to see is we want to see a significant drop in the flow restriction. And remember, there are factors that influence this flow measurement. So we're going to compare it exactly to its own flow measurement. We get all kinds of variations based on the type of components, the vacuum, the precision of the readout, and the substrate. But there's no real absolute that you want to compare all DPFs against. You want to compare them against themselves. Now, what's really valuable is there are some manufacturers on the market that have given information to show you what you should be expecting. There's a DPF manufacturer that measures the flow of the DPF when it's brand new. So Redline, when they manufacture, they measure the flow rate of their that specific DPF before it goes out the door. And you can call Redline and you can get the flow rate for that DPF, brand new. Now, I will tell you, you need to make sure that you are testing on the same equipment that these measurements, that these initial flow rates are tested on. So Redline uses the filter therm flow tester. So having the same equipment is really critical. You don't want to use manufacturer A's flow chart with equipment B because they won't necessarily line up. Now, FSX, which is on the right, they have actually done sampling of DPFs in their market, and they publish a chart of what is kind of averages for those DPFs. So those are great too. And again, remember that those apply to the same processes, the same type of machine. So be careful when you're using those charts. So then after flow, we're going to weigh the DPF and compare them before and after, see if we should have lost weight. We've de-ashed soot out, we've baked that soot, and then we've de-ashed it again. So we should have taken a lot of stuff out. And this is actually where the weight really interacts well. The weight numbers really interact well with the flow numbers. For instance, if we see the flow really drop a lot, but the weight hardly changes, we know that almost all the soot was face plugging, was right at the top of right at the inlet. That engine was not pushing soot into the cells, most likely from idling or maybe even exhaust leaks. But we can say, hey, the flow dropped a lot because the face was plugged and it wasn't letting anything through, but hardly any ash came out because all of it was sitting right on the face. And a little fun fact, we have found that on average, highway heavy duty trucks, they hold about 250 grams. Now, granted, there's lots of filter sizes, but about the average is about 250 grams. And remember, don't do any of your repairs until after you've gotten this after weighing. Once you've done it, go ahead and do your repairs, because then you have a before and after that match. All right, so we're gonna do the wire test again. We're gonna put in that inlet, find out what's left inside. Does it feel different? Are the cells clear of soot? Does the inlet kind of feel like the outlet now? And at this point, this test really gives us a good indication of, does there need to be a second round of cleaning? Did we get all the soot out? Did we get those plugs out? Yeah. And heaven forbid, but it will also tell you, did the DPF get melted while it was in the oven? So hopefully that doesn't happen to you guys, but it will tell you right away if your wire test before and after sees that. One of the things I should mention, I just was thinking about, is that when you put the wire in, soot will leave like a little black mark, a little bit of black soot on the end of your wire. And when you do the wire test afterward, if you see any of that black soot on the end of your wire, you may need to go for a second round of cleaning. So we're going to finish up. We've cleaned and gone through the heating cycle. We've removed all that soot. What do we see now on the filter? We've got all the soot taken care of. Can we see more damage on the filter? More damage on the face of it that was hidden by soot before the cleaning? And this is a good time to check to make sure we didn't do any damage while we were cleaning it. And at this point, I would have my techs taking pictures of everything so that we have a before and an after set of pictures. So finally, we're going to wrap it up by putting this all into our documentation, everything that we can now give to our customer. What is the results of our flow test and our weigh? How did our wire test go? Did it pass? Did it fail? Did we see any cracks? And here's where we would record that. And it would then go into, in our system, it goes into the previous services list so we can see before and after weight. And you can see the before and after weights, and you can record all this and then give it to your customer. So that pretty much wraps it up. We at FilterTherm, we use what we call the 8-step process. So I've gone through a little more than 8 steps, but this is a flow that works with the equipment that we produce. And so inspect and document, wire test and weigh, flow and de-ash, bake, and then you do it again. De-ash it, flow it, wire test and weigh it, and then inspect and document it. So I hope, guys, you've gotten a little taste, but not too much of my engineering background thrown in there. And I would love to hear from you guys if you had any questions later on. My info's on the screen. If you're interested in equipment or anything else, call the sales guys. They're up there. And then our websites, DES Direct is our main site. That's us. FilterTherm.com is that FilterTherm product line that we build. FilterTrack.direct, that is the documentation software we use. It's actually all web-based. You can use it on a browser. All our guys use it on a tablet. And if you're interested in it, you can get a 30-day trial. I think it's a 30-day trial going on. It lets you see kind of what to track and how we track it. And then REP Direct is the red line emissions product website. So, all right. So Adam, I see you said, have you ever used a pressure washer to wash through filters? I would not recommend a pressure washer. Now, I saw you said a power washer. I would not recommend a power washer for a couple of reasons. High pressure air and water like that can actually damage filters. I've seen systems that use a high pressure air, and they're very clear they need to be clean, dry air. And I've seen those systems get water in them and literally water jet the face of the filter. So I'd be concerned about the pressures that you guys are putting through. Also, with a power washer, the cells are really long. And when your power washer hits the beginning of that cell, it's designed to disperse all of that flow through the cells. And so what you end up getting is you get cleaning right at one end of the filter. Your water and your pressure doesn't end up getting through the whole filter because it diffuses so much right at the very beginning. And so those would be my two kind of concerns with using a power washer. One is damaging, and two is diffusing kind of your cleaning ability through the filter. Well, guys, if you have anything else, go ahead and type. If you think of something later, go ahead and email me. And I will try to get back to you with as best I can. So, thanks, Sandy. Thanks. Hope you guys love this and got a new in-depth view on cleaning.